Okay, so for the backside on number 3, it says find the volume of the solid formed by y equals x squared and x equals 2, and the x-axis about the line x equals 5. Okay, I don't like how that's worded because I feel like we're getting kind of confused, but going about that line means that's the line we're rotating around. Okay, we have the graph y equals x squared. That's this curve right here. It's a parabola. The line x equals 2, that's this line right here. Okay, it's a straight vertical line, and we're going about, or we're going to rotate around the line x equals 5. So it would be that line right there. Does that make sense? We're taking this shape and we're rotating it around that line. Okay, so we're taking it and rotating it around. It's going to make a circular shape. Okay, I like to draw it kind of flipped over that. So you're taking this and kind of reflecting it over that line. So the easiest way for me to think of that is, hey, how far away is that 2 from that middle line now? It's 3 away. So if we're at 5, you would think the other line would be at like 8 and have a parabolic shape over here too. That's what's going to end up happening when I rotate it around. Okay, that's the shape it's going to make. So we're finding volume. So to find volume, we're going to integrate. When are we so if we cut this shape in half, if we slice this shape, what would our cross sections look like? They'd be washers still, because we always want to do it so the cross sections are the same. If we cut it horizontally like this, except even, it would make this washer shape. Okay, it'd be really thin at the top and wide as it got towards the bottom with a giant hole in the middle. Okay, from here to here, it would be a big old hole right in the center of that spin. Okay, so from when to when do I need to integrate this shape? When do I start stacking washers and when would I stop stacking washers? From 0, because here would be a washer right here. From 0 out there to up here where it would be a washer right here where it would almost be paper thin there on the top. From 0 to 4 is when I would stack my washers. 0 to 4, that's the top of my shape because that's when it intersects the line. It's y values because my washers they go horizontally now. Okay, so 0 to 4 are what kind of numbers? They're y's, so what kind of equation is it? dy. That means when I plug in an equation right there, it needs to have y's in it, not x's. All right? Cool, we figured that out. Let me redraw that real quick. All right, next thing we got to do is find out the area of my cross section. My cross section are washers, we said. Okay, so to find the area of a washer, we go big circle minus little circle. Every time we find the area of a washer, that's what we try to do. And the area of a circle is pi r squared. Pi r squared. Big minus little. It's always going to be the same. All we need to figure out is the radius of the big circle and the radius of the little circle. So, thoughts on what the radius of our big circle is going to be? From 5. So we're starting here in this middle to where? To the outside line. That's correct. From there to there. From there to there. From there to there. Why did we start at 5? It's a radius. We want to go from the middle out, and we always go from the right to the left. Okay? Note, I had issues with this first period that they wanted to work with this side over here. I don't know what the equation of that line is. I hand drew that thing. Okay, all I did was flip that over the x. I don't know what that equation is, so I can't really I can't use that for anything. I know this one, though. So we're going from the center, which is at 5, to this outside line. So it's got to be 5 minus the square root of y. Where are you getting the square root of y from? We've got this right here, and we need to get x by itself. So she said take the square root of y. That would be equal to x. So good. That's what I want to include there. Oh, I meant y. Sorry. our equation needs to be a dy equation. We said that in the beginning. It needs to be dy because we're stacking vertically. We had to get that equation right there as x equals, so we had y's in there. Good. There's our first line. Now we need to go with the small circle. So our small circle, we're probably starting at the center of our circle again, which is here. We're going from the center to where? To 2. From there to there. From there to there. From there to there. Okay, so we're starting at 5 minus the inside curve, which is 2 here. Okay, I can factor pi out because they both have pi in them. 5 minus square root of y squared, big circle. Can I make that 25 minus y? Can I make that 25 minus y? Right here. 5 minus y squared. Square the 5, square the square root. It's 25 minus y. No. What would I have to do instead? You'd have to FOIL it. So do we want to do that? Nah. Just leave it. 5 minus square root of y squared. Okay. The second one, that would be pi. We factored that out. 5 minus 2. It's 3 squared. So instead of writing 5 minus 2 squared, just do that. That's 3 squared 9. Questions on how I set that up? No, we always want to go from the outside in because we're not rotating around this line. We would have done that the other day when we rotated around, if we rotated around the line right there, but that's not what we rotated around. We rotated around the line 5. So we got to go from there to the outside and there to the middle. That's what you have to start. Yeah, that's considered your top line. Go ahead and plug that in your calculator. So math 9, math 9 from 0 to 4, parentheses 5, I forgot my parentheses 5 minus square root of y, close it, squared, minus 9, dx or dy in this case. Hit enter. It's going to take a second because we're doing a weird y value. 18.664. Is that my real answer here? No, I still got to multiply that by pi. And again, if you're smart, multiply by pi in the beginning. I'm just trying to be silly so we don't forget it. There's my final answer, 58.643. Questions?